motor. And this thing is insane. It has an RPM of 30,000. In fact, it's over 30,000.
In a move that could redefine the balance of power in the global EV race, BYD has unveiled a groundbreaking innovation, a 30,511 RPM high-performance motor paired with a 1000V charging system. One of the most advanced and powerful setups ever mass-produced. This motor isn't just an incremental upgrade. It surpasses Xiaomi's V8's 27,200 RPM unit and dwarfs the 20,000 RPM motor found in Tesla's Model S Plaid. At 580 kilowatt per module, the numbers point to a seismic leap forward in EV propulsion technology. With specs that leave Tesla in the dust and a charging system that redefines what's possible, BYD isn't playing catch-up anymore, it's taking over. And if Elon Musk can't respond fast enough, the EV crown might quietly and permanently slip out of Tesla's hands. Keep watching to find out more. Why would BYD need a 30,000 RPM motor? BYD has just unleashed something truly wild in the world of electric vehicles. A motor that spins at over 30,000 RPM. To put that into perspective, that's faster than the electric motors in both Tesla's Model S Plaid and Xiaomi's SU7 Ultra, two of the fastest EVs on the market. But that raises an important question. Why does an electric motor even need to spin that fast? Is this a game-changing innovation that will redefine performance, or is it just another flashy number designed to grab headlines? There's no denying that a high RPM motor brings certain advantages, but it's not without its downsides. Pushing a motor to such extreme speeds introduces a whole new set of challenges that most automakers prefer to avoid. Electric motors generate power by spinning a rotor inside a stator, creating the force that drives the wheels. In simple terms, the faster the motor spins, the more power it can produce relative to its size. That means BYD can make their motor smaller and lighter without sacrificing performance, which can help with efficiency, acceleration, and overall vehicle dynamics. This approach makes sense for a company trying to squeeze more power out of a compact design. A high RPM motor allows for better energy conversion, which could mean faster speeds, better throttle response, and even improved efficiency under certain conditions. But while all of that sounds great on paper, there's a reason most EV manufacturers don't push their motors to such extreme speeds. There's no denying that a 30,000 RPM motor is an engineering marvel, but it also introduces some major trade-offs. The first and most obvious challenge is heat. The faster a motor spins, the more heat it generates, and that heat has to go somewhere. Managing excessive heat is a nightmare for engineers because if a motor gets too hot, it becomes inefficient and starts degrading faster. Cooling systems need to work overtime to keep temperatures in check, and if they fail, performance drops, efficiency takes a hit, and reliability becomes a serious concern. That's why most automakers opt for motors that spin at more moderate speeds, striking a balance between power and efficiency, rather than going all in on raw RPM numbers. Another challenge comes with gear ratios. Most electric cars use direct drive, meaning the motor is directly connected to the wheels without a traditional multi-speed gearbox. But when a motor spins at 30,000 RPM, it needs a reduction gear to bring that speed down to something actually usable for driving. This adds extra mechanical complexity, which could mean higher costs, more maintenance, and potential long-term durability issues. Then there's the question of battery efficiency. A high RPM motor might be great for short bursts of power, but at higher speeds, it could end up draining the battery faster than a more traditional motor design. That means even if the car is incredibly fast, it might struggle with range efficiency, which is a huge consideration for EV buyers. But if you thought a 30,000 RPM motor was impressive, BYD has another trick up its sleeve, and this one might change the EV game forever. A bigger deal than the motor. While the 30,000 RPM motor is grabbing all the attention, BYD has actually been working on something that might be even more revolutionary: their 1000-volt charging system. This system is capable of 1000 kilowatt charging, which translates to something pretty unbelievable in the EV world. It can add around 450 kilometers of range in just 4.5 minutes. That's almost as fast as filling up a gas or diesel car, which eliminates one of the biggest drawbacks of EVs: slow charging times. If BYD can make this charging tech widely available, it could be a massive step toward making EVs as convenient as traditional cars. The problem with EV adoption has never been just about range. It's about how quickly you can get back on the road. BYD seems to have figured out a solution to that problem, and if their charging infrastructure can keep up, this could be a game changer. At first glance, a 30,000 RPM electric motor sounds like an incredible leap forward. The raw numbers are undeniably impressive, and it's a bold move from BYD to push motor speeds this far. But whether this actually translates into better real-world performance is another question entirely. While a high RPM motor offers benefits like faster acceleration and more compact design, it also introduces challenges like cooling issues, increased mechanical complexity, and potential battery inefficiency. On the other hand, BYD's fast-charging technology might end up being the real headline here. If they can roll it out successfully, it could solve one of the biggest barriers to EV adoption, making their cars more practical for everyday users. So, is this new high-speed motor a breakthrough, or just another spec sheet flex? Only time will tell. But one thing is clear: BYD isn't here to play it safe. They're pushing the limits of what EVs can do, and whether this gamble pays off or not, it's forcing the industry to sit up and take notice. What caught many people off guard was the fact that BYD didn't reserve this cutting-edge technology for its high-end models. The Han sedan and Tang SUV, both positioned as mid-tier vehicles, are getting this revolutionary new platform. These aren't supercars or ultra-premium models, but they are now equipped with electric motors that, as far as current data suggests, are the fastest in the world. With an insane spinning speed of 3,511 RPM, BYD has set a new benchmark in the industry. What makes these motors even more impressive is their sheer power output. At 580 kilowatt, a single motor packs an almost absurd amount of power into a compact, lightweight design. Weighing in at approximately 70 kilowatts, this motor is remarkably power-dense. For comparison, two of these motors together weigh about half or even less than a traditional six-cylinder combustion engine, while delivering exponentially more power. The question then arises: how does an internal combustion engine even hope to compete with that level of efficiency? The answer, quite frankly, is that it doesn't. BYD isn't just making incremental improvements, they're pushing the boundaries of electric motor technology. To put this into perspective, Xiaomi's brand new V8 electric motor, which is already considered an industry leader, tops out at 27,200 RPM. BYD, however, has taken things further by increasing that figure by 10%, a substantial leap considering how optimized these motors already are. Now, let's compare this to Tesla's lineup. The Model S Plaid, often regarded as one of the most performance-oriented electric cars in the world, has a motor that spins at around 20,000 RPM. The Model S and Model X Plaid versions max out at approximately 23,000 RPM, while the Model 3 and Model Y motors operate within the 17,000 to 19,000 RPM range, depending on whether they're positioned at the front or rear of the vehicle. BYD's motor surpasses all of these by a massive margin. Are higher RPM electric motors actually better? At first glance, it might seem like simply pushing for a higher RPM is a flex more than anything else, but there's actually a strong performance advantage to having an electric motor capable of such speeds. Generally speaking, higher RPM motors allow for greater efficiency and improved power delivery, particularly in performance-focused electric vehicles. The ability to spin faster means more effective energy conversion, leading to higher torque output and quicker acceleration, which is exactly what EV manufacturers are aiming for. However, as with anything in engineering, there are trade-offs. While high RPM motors are generally superior in terms of performance, they also introduce thermal challenges and durability concerns. The faster a motor spins, the more heat it generates, which means additional cooling systems are required to ensure it operates efficiently. This also leads to higher wear and tear, so materials and engineering solutions need to be top tier to prevent mechanical issues in the long run. What BYD has done here isn't just about bragging rights. This is a massive technological leap that could change how electric motors are designed in the future. If they have successfully managed the cooling and durability aspects of these ultra-fast motors, other automakers will have no choice but to catch up. The fact that BYD is introducing this level of technology in their mid-tier cars, rather than reserving it for a limited production hypercar, only makes this development even more impressive. One of the biggest advantages of high RPM electric motors is their efficiency. A faster motor speed directly translates into better energy conversion, allowing the vehicle to extract more power from the battery with minimal losses. This improvement might not be massive, maybe just a few percentage points, but in the world of electric vehicles, even a slight increase in efficiency can make a significant difference. A high RPM motor also means increased top speeds. While this might not be a game changer for the average driver commuting to work, it does matter for enthusiasts and performance-oriented vehicles. Speed, after all, is a major selling point for many high-performance EVs, and a motor capable of spinning at 30,000 RPM is a strong step toward achieving even more exhilarating acceleration and velocity. Another key advantage comes in the form of gearbox simplification. Internal combustion engines require complex multi-gear transmissions to optimize power output at different speeds, but high RPM electric motors can utilize simpler gearing or even direct drive setups. While this benefit is more relevant to traditional engines, there are still advantages for EVs. With higher RPM motors, manufacturers can reduce mechanical complexity, leading to fewer parts that can break down over time. A crucial benefit of a high RPM electric motor is the ability to generate the same power output while being physically smaller and lighter. This is exactly what BYD has achieved with its groundbreaking 3511 RPM motor, which has been specifically designed to be 25% lighter than its lower RPM counterparts. A smaller and lighter motor significantly impacts overall vehicle weight, leading to better handling, improved acceleration, and increased driving range. The reduction in mass allows the car to be more agile while also consuming less energy, making the vehicle more efficient in the long run. This efficiency also extends to range. A well-optimized high RPM motor can improve battery efficiency, which in turn translates into a better driving range. The more efficiently an electric motor converts energy, the longer the vehicle can travel on a single charge. However, the jump from 20,000 RPM to 30,000 RPM may not result in a drastic efficiency gain, perhaps only a few percentage points. But in an industry where every bit of efficiency matters, even a small improvement is a worthwhile gain. But just when you think it is all about speed and raw power, there is another layer to this breakthrough that could redefine the entire EV design philosophy. It is not just about how fast the motor spins, it is about what that speed makes possible in terms of weight, size, and energy savings, the challenges of running motors at insane speeds. As with any technological advancement, there are trade-offs. Increasing the rotational speed of an electric motor introduces challenges that engineers must overcome. One of the biggest concerns is durability. The faster a motor spins, the more stress it places on its internal components. Bearings, in particular, are subjected to extreme forces at such high speeds, which means they must be designed with high-precision materials and cooling systems to ensure longevity. Heat management is another significant challenge. Higher RPM generates more friction and, consequently, more heat, which requires advanced cooling mechanisms to prevent overheating and efficiency loss. Without effective heat dissipation, a motor spinning at 30,000 RPM would run the risk of premature wear, reduced efficiency, or even failure. This is one of the reasons why automakers carefully balance motor speed with reliability, ensuring that their designs can withstand the intense demands of high RPM operation. BYD claims that its new motor's efficiency has been improved through smaller, lighter gearing and an overall weight reduction. The company also asserts that this motor helps achieve greater EV range and enhanced performance, but the real test will come when these vehicles are put through rigorous, real-world testing. If BYD has successfully addressed the challenges of heat and durability, then this high RPM motor could set a new standard for electric vehicles moving forward. The faster something spins, the higher the chance it could spin out of control. It's basic physics. Any minor defect in the motor's material or assembly could lead to catastrophic failure when operating at extreme speeds. This is why high RPM motors aren't just about power and efficiency. They demand exceptional durability and precision engineering. Material strength plays a massive role here. Motors operating at over 30,000 RPM experience intense mechanical stresses that standard materials simply cannot withstand. Stronger, high-quality materials are essential to prevent wear, deformation, or outright failure under extreme conditions. Naturally, this adds to the cost and complexity of production. BYD has acknowledged this challenge in their official press release, stating that their new motor utilizes N50H high-energy magnets, which boost magnetic performance by 18% and reduce current losses by 44%. This is a significant improvement, allowing the motor to maintain efficiency while handling intense rotational speeds. To further optimize performance, the motor features a 0.2mm ultra-thin silicon steel sheet to minimize iron loss, which is a major factor affecting efficiency at high speeds. Additionally, BYD has implemented a 10-layer short-distance winding design, reducing copper loss by 21%, ensuring that less energy is wasted as heat. One of the more impressive advancements is in dynamic balance precision, which is controlled at 50 millidegauss, while the industry standard sits at 100 millidegauss. This essentially means that BYD's motor is twice as precise as the typical high-performance electric motor, reducing vibration and increasing longevity. Advanced cooling to prevent overheating. High RPM motors generate significantly more heat, which presents another major engineering challenge. Without proper heat dissipation, the motor's efficiency could plummet and components could degrade rapidly. BYD has taken this seriously, developing an advanced direct cooling refrigerant technology to optimize heat dissipation. This system doesn't just focus on cooling the motor itself, it extends to other critical vehicle components to ensure temperature regulation across the entire powertrain. This level of cooling is necessary to keep high RPM motors running efficiently. Without it, the increased friction and electrical losses at such speeds would lead to rapid overheating, causing energy inefficiency, reduced performance, and potential long-term damage. Tesla has faced similar challenges with their high-performance Model S Plaid motors, which spin at around 23,000 RPM. While Tesla's motors are already considered high-speed, BYD has pushed past that by nearly 10,000 additional RPM, making effective cooling even more crucial. High RPM motors like BYD's latest design and Xiaomi's V8 motor undeniably offer major benefits in size, weight, efficiency, and power output. By reducing the size and weight of the motor while increasing its rotational speed, automakers can produce vehicles that are lighter, faster, and more energy efficient. A smaller motor that can produce the same power as a much larger one means better weight distribution, improved handling, and potentially longer driving range. However, all of these advancements come at a cost. Higher RPM motors require more expensive materials, advanced manufacturing techniques, and sophisticated cooling solutions. Every percentage gain in efficiency or reduction in weight comes with an associated increase in development costs and production complexity. While BYD's engineering feats are impressive, the long-term question remains, is the added cost worth the benefits, and how will these high RPM motors perform in real-world conditions? Higher RPM motors come with a price, literally. They are more expensive to produce, require specialized materials, and demand significantly more cooling than their lower RPM counterparts. Tesla's motors currently operate at much lower speeds, typically between 17,000 and 20,000 RPM for the cars sold to the vast majority of the world. This means BYD's new high RPM motor isn't just a small technical leap, it's a significant shift that could push the entire industry toward even more efficient, compact, and high-performing electric motors. Right now, Tesla undeniably leads the industry in efficiency. Their electric vehicles, from the Model 3 to the Model X, have consistently demonstrated superior energy consumption per mile compared to most competitors. However, that dominance may soon be tested. With BYD's introduction of the 1000V platform, combined with its latest advancements in battery technology, the gap could begin to close, and possibly even reverse. BYD's next-generation Plaid batteries. BYD is not stopping with just high RPM motors. Alongside these innovations, the company is launching a new generation of Plaid batteries, which could redefine how efficient and powerful electric vehicles can be. Unlike the previous version, these new Plaid batteries come in two different variants, one being a short Plaid battery, which is about half the length of the existing Plaid model. The goal behind this design shift is to increase energy density, improve thermal management, and optimize weight distribution. Battery advancements play a crucial role in efficiency, especially when paired with motors that operate at higher RPMs. More compact, powerful batteries mean vehicles can sustain high performance without sacrificing range. This could also reduce charging times significantly, particularly when combined with ultra-fast 1000 kilowatt charging, another technology BYD is developing to further refine the EV experience. For years, Tesla has held the efficiency crown, but BYD's rapid technological advancements suggest that the balance of power in the EV market might be shifting. While Tesla's engineering remains at the forefront, BYD's new battery and motor innovations could reshape the industry's benchmarks. The ability to pair a smaller, more powerful motor with a next-generation battery system means that BYD could potentially deliver higher efficiency, longer range, and better overall performance in the coming generations of electric cars. Over the next 6 months, as these models begin to roll out, it will become clearer just how much of a game-changer this technology truly is. The key question now is whether Tesla will respond with its own innovations, or whether BYD will take the lead in setting the next standard for electric vehicle efficiency. While BYD's new high RPM motor is a major breakthrough, it's just one part of a much larger battle playing out in the EV industry. The shift toward smaller, faster, and more efficient motors isn't just about performance. It's about making electric cars lighter, cheaper to produce, and more efficient overall. The key question is how much of an impact these motors will have on real-world driving experiences, particularly in areas like range, durability, and long-term reliability. One of the biggest advantages of higher RPM motors is power density. BYD's new motor, despite producing an insane 580 kilowatts from a compact unit weighing just 70 kilograms, offers a massive weight advantage over traditional internal combustion engines. Consider a typical 6-cylinder gasoline engine, which can easily weigh 200–250 kilograms while producing far less power. Even two of BYD's motors combined would still weigh less than half of that, while delivering several times more horsepower. This weight reduction matters more than most people realize. In an EV, every kilogram saved means more range, better handling, and lower energy consumption. This is especially crucial for performance-oriented electric cars, where maintaining balance and weight distribution can dramatically affect how a car accelerates, corners, and brakes. The biggest challenge for high RPM motors. One of the most overlooked challenges of running motors at 30,000 plus RPM is heat management. Spinning at such high speeds generates significant amounts of friction, which leads to excess heat buildup. If not properly managed, this can degrade motor efficiency, shorten lifespan, and in extreme cases even cause overheating issues. BYD has tackled this with a direct cooling refrigerant technology, specifically designed to dissipate heat more efficiently than traditional liquid cooling systems. This is critical because a motor operating at such high speeds needs to maintain consistent thermal performance to prevent power loss or component failure. However, heat isn't just a motor issue. It affects the battery as well. High-performance electric motors demand more power, which puts additional strain on the battery pack. BYD's solution? A more advanced battery cooling system that pairs silicon carbide power modules with its new Plaid battery design, allowing for faster heat dissipation and higher sustained performance. BYD's transition to a 1000-volt platform is another key development that could redefine charging speeds and efficiency. Most EVs today operate on 400 volts or 800 volts architectures, with only a few high-end models, such as the Porsche Taycan and Lucid Air, utilizing 800-volt technology. This could be a huge advantage for BYD, allowing their future EVs to charge at speeds well beyond what's currently possible with Tesla's superchargers. If BYD successfully rolls out this technology at scale and at a lower cost, it could change how quickly EVs recharge, which has been one of the biggest concerns for mainstream consumers switching from gasoline cars. For now, Tesla still holds the efficiency crown, but that could change as new models with these advancements hit the market. Historically, Tesla's energy consumption per mile has been the best in the industry, thanks to its aerodynamic designs, optimized powertrains, and highly efficient software. However, BYD is rapidly closing the gap. The combination of a lighter, more compact motor, improved battery chemistry, and next-gen cooling systems means that BYD's upcoming models could match or even exceed Tesla's efficiency in certain scenarios. If that happens, BYD might not just be a competitor anymore. It could become the industry benchmark. With the next wave of EVs set to launch within the next 6 months, it's only a matter of time before we see how these technologies play out on the road. The real question is, will Tesla respond with an even bigger leap in efficiency? Or will BYD officially take the lead? The materials arms race. Stronger, lighter, and more efficient. One of the most overlooked yet critical aspects of high RPM motors is the materials used to build them. When a motor is spinning at 30,000 plus RPM, the mechanical stress on the internal components skyrockets. This means standard steel and copper wiring aren't enough anymore. Manufacturers need to use more advanced materials to maintain structural integrity while keeping weight low. BYD's motor isn't just faster, it's built differently. The company has opted for N50H high-energy magnets, which offer higher magnetic strength while reducing energy losses. But that's just one part of the equation. The 0.2mm ultra-thin silicon steel sheet used in the motor is another breakthrough. By reducing the thickness of these sheets, BYD minimizes iron loss, which directly improves efficiency. However, using thinner and stronger materials isn't as simple as just cutting things down to size. These materials have to withstand immense centrifugal forces without deforming or breaking. This is why precision engineering is critical. Even the smallest defect in the material or a slight imbalance in the rotor could lead to catastrophic failure at such high speeds. This is where dynamic balance precision comes into play. BYD has pushed the limits by controlling it down to 50 millikilohertz, which is twice as precise as the industry standard. This means fewer vibrations, less energy wasted, and a longer-lasting motor. In short, the difference between BYD's motor and a traditional one isn't just about speed. It's about how much thought has gone into making it run efficiently without falling apart. One of the biggest drawbacks of high RPM motors that rarely gets discussed is noise and vibration. The faster something spins, the harder it is to keep it running smoothly. Every little imperfection, from tiny variations in weight distribution to inconsistencies in manufacturing, can lead to excessive vibrations, which in turn create noise and reduce efficiency. At lower RPMs, these imperfections might not matter much, but at 30,000 RPM, even the tiniest imbalance can make a motor sound like a jet engine and lead to higher wear and tear. BYD claims its new dynamic balancing precision significantly reduces this issue, but it's still a challenge that every manufacturer trying to push motor speeds has to deal with. This is where Tesla's lower RPM approach has been a huge advantage. By keeping its motors in the 17,000 to 20,000 RPM range, Tesla can use simpler and more cost-effective balancing techniques, which also helps with overall durability. The question is, will BYD's high RPM motor be quiet enough and durable enough for long-term use, or will it need extra noise-dampening technology to prevent cabin vibrations? If these motors are to be mass-produced and widely adopted, noise reduction will be a key factor in ensuring they're suitable for daily driving and not just high-performance EVs. Another interesting possibility with high RPM motors is their potential to improve regenerative braking. Regenerative braking systems rely on the motor's ability to convert kinetic energy back into electrical energy when slowing down. Theoretically, a motor spinning at higher RPMs should be able to recapture more energy because of its ability to generate higher back electromotive force. This means that a high RPM motor like BYD's could allow EVs to recover more power when decelerating, further boosting range without needing bigger batteries. If optimized correctly, this could be a major efficiency advantage, making EVs even more practical for long-distance driving. However, regenerative braking at such high speeds also presents new challenges. The system has to be precisely calibrated to avoid jerky or inconsistent braking. If not done right, it could lead to unstable handling or unnecessary strain on the motor and battery. So while there's potential for better regenerative braking performance, it remains to be seen how well it will work in real-world applications. If 30,000 RPM is possible today, the next logical question is, how much further can we push this? Could we see 40,000 or even 50,000 RPM motors in the near future? Theoretically, yes, but there are some serious limitations that need to be addressed first. The higher the RPM, the harder it becomes to manage heat, vibration, and material durability. At some point, the diminishing returns of increasing RPM outweigh the benefits, unless new materials and cooling technologies come into play. This is where next-generation superconducting materials could be a game-changer. Some researchers are already working on high-temperature superconducting motors, which could dramatically reduce energy losses and heat buildup, allowing for even higher RPMs without the same drawbacks. If this technology matures, we might see EV motors with speeds that were once considered impossible. So, after all this talk, one thing's clear, that BYD's 30,511 RPM motor is pushing the boundaries of what's practical. But if history has shown us anything, it's that automotive technology doesn't stay still for long. Tesla, BYD, and other manufacturers are in an arms race to make their EVs more efficient, more powerful, and cheaper to produce. The question is, who will take the next big leap? The future of EVs is definitely looking exciting, and it's going to be fun watching how this all plays out. Catch you next time